Good day. The COVID-19 pandemic has forced many changes to educators' teaching approaches and highlighted the role that technology and the fourth industrial revolution play in the future of tertiary education. Many educators have had to adapt to these changes and adopt strategies to benefit the students' prospective positions in the various industries. In the University of Technology institution studied, the jewellery students were trained in CAD from 2013 onwards. As the CAD lecturer, I noticed a significant change in each intake between 2018 and 2020 of the students' ability to adapt to the CAD software in their first year of being taught. With students comprehending the commands quicker and easier, it was apparent that the teaching strategy had to be revised to the students' competencies, which would also benefit their future employment in the industry. As confirmed by Lynn, Ula, and Harib, who note that a solid foundation in CAD/CAM at the undergraduate level is vital for generating economic growth. The change in assessment of the students' CAD-related capabilities will help develop a more student-led teaching strategy. In this strategy, the students are placed in the center of the learning experience, giving them greater responsibility for their learning. Rowley, Fook, and Glazard explain that student-led learning empowers students to take ownership of their learning. This strategy is essential to implement in tertiary education as it prepares students for the working environment through autonomy and self-expression. However, Rowley, Fook, and Glazard caution that a student-led teaching strategy should be a collaborative effort with the lecturer. The more experienced lecturer should act as a facilitator in the teaching process. The primary objective of this research is to investigate the reasons for the increased application of the jewellery students' computer skills and understanding of technology, specifically in CAD, through a case study. The research followed a mixed method approach that consisted of a literature review and an online questionnaire. The participants for this project consisted of the entire student cohort of the tertiary institution's jewellery program of the 2020 academic year. The first section of the questionnaire sought to understand what, if any, the students' previous exposure to or use of technology was prior to starting at a tertiary institution. At least 80% of the students stated that they had used or were still using smartphones, laptops, social media such as Facebook, Instagram, and Twitter, and streaming platforms such as YouTube, Netflix, and Spotify. Over 60% of the students still used gaming platforms such as PlayStation and Xbox for entertainment and to connect with their friends. 69% of the students use smart assistants and online learning platforms to assist them with research and learning. While few of the students had used any of the other technologies listed, such as software programming, CGI or animation, robotics, and artificial intelligence, most had knowledge of these technologies. With so many of the students showing an aptitude for the 3D software in their CAD class, it could mean that just the exposure to various technologies provides ease and confidence with using the newly introduced technology. Another possibility could be that the knowledge of 3D software provides them with aspirations of using these technologies. It can also be postulated that the students are further influenced by their newfound peers at the tertiary institution who have had previous exposure to these technologies. The next section of the questionnaire sought to understand how the students feel about their progress and what they think their competency is in CAD. Figure 2 shows that 69% of the students grasped CAD tools once the tools were explained by the lecturer. This clear grasp of CAD tools implies that the lecturer-led teaching remains important and can be implemented for online learning through online tutorials, explaining and showing the various software tools in instructional and step-by-step videos. Figure 2 further indicates that it took a few lessons for some students to understand the software tools taught, and only one student took a few months to comprehend these tools fully. A student who initially struggled with CAD enjoyed it once they understood it better. I just started liking CAD now, as I have a way better understanding how and why things are done the way they are. Several students mentioned that they would like to have more classes, access to laptops, and the CAD software to improve their CAD skills. The questionnaire then examined obstacles the students faced both before and during the COVID-19 pandemic. When asked whether the once-a-week CAD class pre-COVID-19 was enough time spent on CAD, 59% of the students answered no, And when given the option to suggest more hours, 72% suggested more days and/or hours a week. Around half the students suggested 2 classes, and a fifth suggested 3 or more classes. The remaining 7% suggested more hours per class. One student commented, technically 2 classes per week, but realistically 1 class per week will be enough, considering that the students have other subjects to focus on, so more classes might be a bit overwhelming, even though it can be beneficial. During COVID-19, the CAD classes were halved due to social distancing requirements. When asked if the students would be interested in online classes to support their missed class due to COVID protocols, 59% of the students replied yes. When we asked the students if they had access to a computer, 65% answered that they have their own computer, 25% have access to a family computer, and 10% said they could use a computer at the community center, as you can see in Figure 4. Conversely, Figure 5 shows the breakdown of reasons students cannot complete online classes, with 24% not having access to a computer or laptop, 14% not having the right specifications to run the software, and 48% not having access to the software program. 9% of the students cited a lack of data as a problem, and 5% have network coverage challenges. When asked whether the students would do homework if they did have access to a computer with the right specifications and the CAD software, 100% responded that they would revise between classes to further their CAD skills. The final section of the questionnaire gauged the students' opinions regarding possible solutions and concerns they have. The students were also asked their opinions about the Fourth Industrial Revolution and what role they think the Fourth Industrial Revolution will play in their futures. When asked if the students could complete online classes at their places of residence, if they were given a computer and the CAD software, 83% of the students said that they could complete online learning at their residence, as seen in Figure 7. Of the students that could not do online classes at their place of residence, 30% said they didn't have data, and 10% have no network coverage where they live. 20% have safety concerns when carrying around a laptop, and 30% said the environment was not conducive to learning. 20% said they prefer one-to-one classes. We also wanted to know which teaching methods would best meet the students' needs regarding online learning. Figure 8 shows that 72% of the students said they prefer online videos, with step-by-step videos done by the lecturer being the most popular option. 10% cited a combination of 2 or more of the options, and only 1 student responded that they prefer in-person classes. The students were forthcoming with their suggestions regarding online learning. Several students mentioned instructional videos as a possible solution, and I quote, "Video instructions are better because one can play back where they missed a step." Another student suggested that the instructional video should be online to be downloaded and viewed anytime. Most of the responses confirmed the importance of the lecturer facilitating any online teaching and that the students would like access to lecturers for guidance. One student suggested the following: if the lecturer cannot be part of the live meeting, then let a diligent student who understands the program well or an online tutor assist the students while going over the lesson. TeamViewer could also be a handy application to show individual students on their program what the problem is and how to fix it. In this instance, an online forum could be a feasible solution where the students can raise their questions and respond to each other, with the lecturer answering at allocated times. Again, a few students reiterated the importance of having access to the hardware and software for successful online CAD learning. One student commented, "Yes, if we can get laptops that have the right specifications to run the Rhino software, we will engage more on online learning via Zoom or live classes, making it easier for us as students to learn the program swiftly." The students were asked what they knew about the Fourth Industrial Revolution. Figure 9 shows that most of the students had some or a reasonable amount of knowledge, while a third of the students admitted that they had no or very little knowledge of the Fourth Industrial Revolution. The questionnaire then asked students in an open-ended question to mention their outlook about the future regarding the Fourth Industrial Revolution. The answers ranged from overwhelming concerns about South Africa's socio-economic issues to concerns about an inability to keep up due to a lack of resources. Some students were worried about the new technology furthering inequality in the country, with one student cautioning, "Increased unemployment may drive economic inequality in society." Another student mentioned that the Fourth Industrial Revolution could drive unemployment by stating the following: I feel it will or is replacing the workforce on the production industries. This means more people are losing their jobs because it is faster and more efficient. A student also voiced this concern. It will make my job obsolete, and that all working class people will be out of a job. The lack of basic amenities in some of the poorer communities in South Africa was also mentioned, with a student stating, our continent isn't ready for that yet. We still have people that don't have access to running water and toilets. We can't really be talking about the prospect of 4IR. These students are concerned with their own development and also how their development will affect the rest of the country, and was very aptly put by the following comment. Not everyone has access to laptops or computers, quality education, and even the internet. How on earth will they catch up while the rest of the world is living in a digital era? This only means one thing for them. They will simply be left out, and that's not the world I want to live in. In conclusion, it is clear that a student-led teaching approach can be incorporated as a teaching method in CAD. However, the students mentioned that they still prefer lecturer input, but are comfortable making suggestions about various teaching methods. Consequently, the students will become part of the CAD teaching methodology and therefore active role players in their own learning experience. This type of research is vital to address the unique challenges faced by South African students. How educators can improve the CAD teaching methodology in South Africa, specifically in jewelry design, should be considered an evolving process that is aligned to and influenced by student abilities and technologies. Thank you.